Okay, guys. I had to stay home to take care of my sick kid today, so I recorded a lecture or I'm recording a lecture on the stuff that you're working on, so it'll be a little something to help you figure it out. But you should be able to do the PDawg on your own without my help. But we're talking about our types of chemical reactions. And there are 5 basic types of chemical reactions you're expected to know. And they represent the most common reactions that we have in chemistry. And the first one is called synthesis. The next one is called decomposition. The one after that is single replacement. And then we'll have another one called double replacement. And then the last one, which is kind of different than the previous 4, but it's very common, one you guys will be interested in, is called combustion. And that one is combustion. There we go. Okay, so we're going to start with the first one, which is synthesis. And running out of space down here. Synthesis is the combining of two elements or simple compounds into a larger compound. All right. And that goes a little something like this. Okay, where we have iron reacting with oxygen to make iron 3 oxide. And now that is obviously not balanced, so I want you to take a minute and pause the video and try and balance this on your own. Or don't and just see what my answer is and sell yourself short, but that's up to you. Alright, so that balances to be 4 irons, 3 oxygens, and 2 iron oxides. But notice how we have right here, where are we? Right, notice how we have right here, we have an iron, which is just an element, an oxygen, which is just an element, and this will produce these two combined. And this is the important feature right here, is this single compound that gets produced afterwards. Okay, so we'll go on to the next one. So that was a synthesis reaction. The next one is another synthesis reaction where we have sulfur dioxide plus oxygen, and these two will combine to make sulfur trioxide. And these are again, this is making a single two species making a single compound, and this would be a synthesis reaction. Okay, the next one is decomposition, and decomposition is the opposite of synthesis. Synthesis is where we combine things to make a single compound. Well, decomposition is where we take a single compound and it breaks up into simpler. It breaks apart into simpler species. Okay, and so our first example is going to be magnesium carbonate, which is a solid. Notice these little scripts over here on the side. This little S right here says solid. Okay, this little S means solid. This G means a gas. These are the states of matter that they will be coming out as once they finish the reaction. So here we have magnesium carbonate, and it will decompose. It will break up into simpler compounds, magnesium oxide and carbon dioxide. And if you want to balance, well, congratulations, you've already done it because it's already a balanced equation. Okay, so the next one is lithium sulfide, again a solid. Will break up into its components, lithium and sulfur. Well, sulfur can become an S8 molecule, which is a really big molecule. It's a solid molecule. And so over here we have our to balance this, we would need 8 sulfurs. And to get 8 sulfurs, we're going to wind up with 16 lithiums to go with. So that's 8, 16, and 1 is the balanced equation for that one. But notice, the big thing to notice is that this is a compound breaking up into its simpler parts. Okay, the next one is called a single replacement reaction. Single replacement. and this is characterized by one element replacing another element within a compound. Okay, and this is governed by something called the activity series, and I will show you guys what the activity series is in your book. And if something is higher up on the activity series, that means it is more reactive than something that is below it on the activity series, and therefore it will replace the more active element will create the compound. And so if we look at an example equation here, we have iron chloride, aqueous, plus solid zinc, make zinc chloride and iron, and just iron. And it looks like I forgot to put in right here that this would be aqueous. Okay, so here we have an ionic compound, FeCl3, reacting with just an element. And this element will replace the iron in this compound. It just takes its place. So zinc then reacts with the chlorine, and when the zinc acts with chlorine, when the zinc here acts with the chlorine, it creates a zinc chloride right here, ZnCl2, and kicks the iron out to become a solid. And so we'll see if we can do a demo of this in class. It's kind of cool, where we just make actually make solid iron at the bottom of a test tube. Okay, so let's see if we have another example here. This is those switch places. Nope, that's our example here. Okay, a double replacement reaction is the next one, and that is two ionic compounds that swap cations, or they can swap anions. It depends on which one you want to choose. Okay, but this is based upon creating an insoluble product. It's usually called a precipitate, or sometimes it's a gas. When a gas bubbles away, that is also an insoluble product, because it's no longer, those things that make the gas are no longer in the reaction. They're leaving the medium, and so they're no longer involved in actually in creating this reaction. Okay, so we're going to start with silver nitrate, an aqueous silver nitrate plus aqueous salt water makes silver chloride and sodium nitrate. And right here, so both of these are aqueous, and so you mix these two solutions together, but it will produce this solid. And when this solid drops out, it stops reacting with everything else, and it leaves behind this sodium nitrate. Now, what really happens here with the sodium nitrate, aqueous sodium nitrate, is that these two ions, the sodium ion and the nitrate ion, don't really combine in the reaction. What they really do is they float around individually, and we're going to do we'll do another interpretive dance that shows a double replacement reaction. You guys will enjoy it, and you'll never forget it. And I also have another story to tell about that. So the double replacement reactions is kind of a funny story. I like that one better. Okay, so that right there, that is the solid product, and it's insoluble, and you've got to have it. Okay, so another one we're going to give you guys is iron sulfide, solid iron sulfide plus aqueous hydrogen chloride, or hydrochloric acid is that one, and that will make hydrogen sulfide gas plus iron chloride. Well, this iron sulfide gas right here is this gas is going to leave the solution. It's just going to, in fact, we usually draw it. We see that it evolves, and it does this. And we draw this up arrow, saying that this gas leaves the reaction, and it's no longer involved, and so we're just left behind with the FeCl2, the iron 2 chloride, in the reaction. Okay, and that gas product drives the reaction and makes everything move towards creating more H2S and FeCl2. Okay, then there's finally our last reaction we're going to talk about is combustion. And combustion is the reaction of oxygen with hydrocarbons or carbohydrates. Now, hydrocarbons have a general formula of this CXHY. So now there's a certain number of carbons plus a certain number of hydrogens, and it's a large class, and there could be any number of those guys. So we just call them hydrocarbons. Or it can react with carbohydrates. Okay, and carbohydrates, like starches or sugars, they have carbons, hydrogens, and oxygens. Okay, so then we throw in there this OZ, so CXHY and an OZ, because you could also have oxygens in there. And that's the general formula for a carbohydrate. Now, they always produce. So here we have butane reacting with oxygen to make carbon dioxide and water. The butane, C4H10, is usually a liquid because you see it in your lighters, butane lighters, little flick your Bic lighters. And when it burns, it creates CO2 and H2O. And those are always the products of this of a combustion reaction, carbon dioxide and water. Okay, then we balance this, and combustions are the ones that have the really difficult balances because we start getting really long numbers. Okay, or really big numbers like 2, 13, 8, and 10 to balance this guy. Okay, so those are our 5 reaction types. Those are the 5 things that you're looking at today in your PDawg. And we will talk more about this and actually how they work if you didn't see this a little bit later. I realize this is a pretty fast lecture and we went through all 5 of them really fast, but it's a video, so you're free to go back and watch it again and catch anything that you missed and correct any errors that you have in your notes. That's all, and I'll see you tomorrow when I get back.